graph an exponential function, and understand its properties. So what is an exponential function? Well, oftentimes we recognize an exponential function because of what it looks like. And when I say that, it's because the variable is in the exponent. It's very exciting. So if we have a variable in the exponent, that shows that we have an exponential function. And a few things about this a and b, and I'm going to go ahead and put parentheses around this b just to differentiate those. So first things first, let's talk about the b, which is the base of the exponent. And we know that b must be greater than 0, meaning it has to be a positive number. Now, more specifically, it cannot be 1. Because if b is 1, right, think about 1 to any power, whether it's 2, whether it's 3, whether it's 4, we could go on. These all equal 1. So if we have a base of 1, we no longer have an exponential function. Okay, so a is just a number, right? No big deal. A can be positive or negative, but a cannot be 0. Because if a is 0, the whole thing is 0, and we no longer have an exponential function. Okay, so just a few things to think about. So now we're going to graph these two functions. We're going to graph f of x equals 2 to the x and f of x equals 3 to the x. We're going to graph it on the same coordinate plane here, and we're going to look at them. So first, let's create a table of values for 2 to the x. Now I'm going to use the same 5 numbers for both of these. We're going to use -2, -1, 0, 1, and 2. So let's go ahead and do this. If I have 2 to the -2 power, remember the negative exponent makes it flip. So we're going to have 1 over 2 squared, which is 1/4. If I have 2 to the -1st, that's 1/2. 2 to the 0, property of 0 exponents, anything to the 0 power is 1. 2 to the 1st is 2, and 2 squared is 4. Okay, let's go ahead and graph this. So at -2, I'm going to go up 1. At -1, I go up 1/2. 0, 1. 1, 2, 2, 4. If I would do 3, 2 to the 3rd power is 8, just for fun. 1, 2, 3, 4, 5, 6, 7, 8. So you can see this has a curve to it. Okay? Okay, that's the first one. Next, let's do, I don't know what that was. Let's do x and y. So again, -2, -1, 0, 1, and 2. So now if I have 3 to the -2nd power, that's the same as 1 over 3 squared, that's 1/9. 3 to the -1 is 1/3. Anything to the 0 power is 1. 3 to the 1st is 3, and 3 squared is 9. Okay, so 1/9, 1/3, 1. You can see they share that 0, 1 point. And then 1, 3, 4, 5, 6, 7, 8, 9. And if we use a 3, 3 to the 3rd is 27. Well, that's off my graph, so I don't have to worry about that. Okay, so if I make this one, okay, sorry about the shaky hand, but it's hard to do this. So we can see that these are similar, but quite different. Now, what do they have in common? Well, if we talk about the domain, they both have a domain of -infinity to +infinity. Because domain is, remember, the input, we can use any x value we want. There are no restrictions on that. So our domain is all real numbers. Now, our range, on the other hand, is 0 to infinity. It goes to infinity because you can see these numbers keep going up. Remember, y is the vertical axis, and these graphs continue to go up and up and up based on the fact that as I plug in bigger values for x, I get larger values for y. But when I have smaller values for x, like -2, you'll notice my fractions are getting small, 1/2, 1/9. They're getting closer to a y value of 0, but they're never going to get there. No exponent is going to give me a y value of 0 for this. So our range is 0, and that is a parenthesis in our range because 0 is not included, right? It's not a bracket. It matters. And with that conversation gives me an asymptote of y equals 0. What that means is that this graph is never going to touch the x-axis. That horizontal line of y equals 0 is an asymptote, meaning these graphs are going to get closer to the line of y equals 0, but they will never touch it. That's what an asymptote is. You can also see that they both go through the point 0, 1, because an exponent of 0 gives us an output value of 1. Now, both of these are growing. These are exponential growth because as you can see in the equations, right, 2 to the x and 3 to the x, the value of b, the base of the exponent, is greater than 1. So because b is greater than 1, we have exponential growth. As b gets larger, so from 2 to 3, the graph rises at a quicker rate, and therefore it's, growing quicker. Now, I know this is already a longer video, but I want to graph one more with y equals 1/2 x. So we can see we still have a b value that's greater than 0 because that's required, but it's smaller than 1, right? So we can now see that b is between 0 and 1, meaning this is exponential decay. So I just want to graph this real quick so we can see what this looks like. All right, so x and y, let's use the same 5 numbers. Oops. So when I have 1/2 to the -2 power, well, negative exponent flips it over to make it 2 squared, which is 4. So 1/2 to the -1 flips it over and makes it 2 to the first, which is 2. And then I have 1/2 to the 0, and anything to the 0 power is 1. 1/2 to the first is 1/2, and 1/2 squared is 1/4. So as I graph this, if I go to the -2 on the x, I go up 4. -2, 1, 2, 3, 4. -1, 2, 0, 1. So you can see this also goes through the point 0, 1. Then I have 1, 1/2, and 2, 1/4. So you can see how this looks different, right? With exponential growth, as we move from the graph left to right, it rises. And in this exponential decay, as we in this graph move left to right, our graph goes down. It decays, if you will. We still have a domain of -infinity to +infinity and a range of 0 to infinity. And we still have an asymptote of y equals 0. All of those are the same. But because b is between 0 and 1, we have exponential decay. That is graphing exponential functions and understanding its properties.